find the missing coordinate dealing with what?
Slope intercept.
Slope. Dealing with slope. So yeah, we were cross multiplying, that's the math we were doing, but we are talking about slope. And the reason that we're going to talk about, that we talked about slope yesterday, is so that today we could write the equations of lines. All right? Now, when I say that to you, let's write the equation of a line. What pops into your head?
Y equals
mx plus b. Mx plus b. So one thing that pops into our head is y equals mx plus b. Very good. That should pop into your head. What's that called? That's the slope-intercept form. Okay, so I want you to read the question that we're getting ready to do, which is 3a. Did I turn this on? Which is 3a.
Yeah.
Is it running? Yeah. Okay. And what's wrong with that? What's different? What's it say? Use point slope. Oh boy. That's the one that we use most often in, as we go through our math life. So we need to talk about that one. We're going to do some slope intercept too. But who remembers what point slope looks like? Anybody? Sam.
Y minus y, or y minus y, or y minus y1, or then slope, and then x minus x.
Okay, I think he got it. He said that point slope, very good, Sam. He said that point slope looks like this. You remember that? Good. Now, in that formula, m, of course, is the slope, because m is our slope letter. And then your point is the x1, y1. That's your point. So if you are going to use point slope, obviously, you gotta have a point and you gotta have the slope. Now, let's look at what they gave us. They gave us -1, 2, and 6, 4. Did they give us a point? Yep, they gave us 2, and we get to pick which one we want to use. Did they give us the slope?
No.
No. So guess what we have to do first? Find the slope. You can't do point slope or slope intercept. You can't do either one of them if you don't have your slope. So here we go. Who remembers how to find slope?
y2 minus y1.
So subtract my y's. So I can take 4 minus 2. And then,
x2 minus x1.
so 6 minus -1. So what does that slope work out to be? 2 over 7. So now pick a point. It does not matter, kids, which one you use. Please don't waste time trying to figure out which one to use. Pick one. Which one you want to use?
Both.
But no, you gotta pick one. Which one? Just pick the first one. We'll just go with the first one. Now, what's it look like? Well, apply your formula. Y minus 2. Remember, the point is the x1, y1. So y minus 2 equals 2/7 x plus 1, because it's minus a negative. You're done. That is the point slope form. So you can stop right there. But you can keep going, and we'll need to keep going.
If we solve ugly, we'll be wrong.
Well, not if you started with this. If you started with this, I would be okay if you kept going, as long as what you did was right. Here's my caution. Why do extra? Because you might make a mistake along the way, right? So, I mean, it's up to you, I guess. But we got to start with this. That's the point slope form. Okay? You're allowed to stop there. That equation is graphable at that point, so we're allowed to stop. Okay? Let's look at the next one. Points are 3, 2, and 5, 5. All right, here we go. Step 1. Maddie, what's the step 1? What do I need to do? Slope. Call that the slope, yep. So our slope will be 5 minus 2 over 5 minus 3. So 3 halves? we'll just go with our first point, because we did that in the last one, and I'm a creature of habit. Does not matter which point you use. Y minus 2 equals 3/2 x minus 3. The biggest, the place that has the most mistakes on here is, you gotta remember that even though you're using, so because you're using y first, you have to use that coordinate first. Don't use the 3 first. Don't say y minus 3. You have to say y minus 2 and then x minus 3. You might want to label this x and y to kind of keep it straight. Easy. So let's look at the next set. The next set says, write the equation of the line using slope-intercept. So the problem is the same. You got 2 points, but now we have to use slope-intercept form. Okay? Kyla, what do you think? What might be a good way to start?
Well, you have to find a slope.
Bingo! Doesn't really matter how we do it, we have to find the slope. So let's find the slope. So 1 minus 5 and 4 minus -1. Make sure I did that right. It's been kind of a crazy day for me. You get -4/5?
Yes.
All right. Now what?
Point slope.
Okay. She says I don't have to do anything differently. I can go ahead and use point slope. So y minus 5 equals -4/5 x plus 1. Is that okay? Yeah.
And then just distribute.
But now I have to go farther, because the directions said we want an answer in slope-intercept form. So the work is the same. To this point, we've done nothing different, but now we have to move on. We have to take it a little bit farther. So y minus 5, somebody said distribute, -4/5 x minus 4/5.
You have to add 5 to address it.
Yep. Remember, slope-intercept form means that y has to be by itself.
Yes.
So I'm going to add 5. Oh, shoot. All right, here we go. We got some fraction work to do. So y equals -4/5 x. Now I have -4/5 plus 5 over 1. So -4/5 plus 25/5. So that'll be 21/5. And there is our final answer. So I had to do a little arithmetic over here. Somebody might say, well, this is for a bunch to get rid of the fractions. You can do that. The problem is you're trying to get y by itself, and if you multiply through, that's going to be 5y. So you have to turn around and divide it back out, which you can, if that's easier for you than just adding the 2 fractions. All right, well, that was a little harder. Let's try another one. I think there's one more, isn't there?
Yeah.
All right, so we've got -3, -2, and 1, 2. All right, here we go, and our job is y equals mx plus b. That's our end goal. So, Mr. Stewart, how you gonna start? Find the slope. And slope is y minus y over x minus x. Notice, even though I'm old and I do this for a living, I'm a teacher, I don't do it in my head. I write it down. I'm less prone to mistakes if I write it down. So what have we got up there? 2 minus negative 2, 4. Oh, whoa, this one's easy. Our slope
Negative
turned
1.
out to be
Negative
1, positive 1,
Oh.
positive 1.
I got.
Did I subtract wrong?
You did it right.
How did I?
The negative should change to a positive.
Okay, yeah.
Make sure you're doing, if you did 2 minus negative 2, make sure you did 1 minus negative 3.
Yeah.
Yep.
That's what I did wrong.
All right, so now we can do our point slope. So y plus 2 equals 1, x plus 3 if I use the first point.
So if you use the other point, you subtract it, right?
Yep.
Okay.
So
All right,
what you just
so
put
over
x
here,
plus
if you use
three.
the other point, it would be y minus 2 equals 1 times x minus 1. I'm going to show you we're going to get the same answer.
Something like that.
So y plus 2 equals x plus 3. Y equals x plus 1. And if I do it this way, y minus 2 equals x minus 1, and y equals x plus 1. See how it doesn't make any difference which point you use? I use the first point here and the second point here, and look at my answers. It doesn't matter what point you use. So if you like that one because there's no negatives, use it. Everybody okay? All right. At some point, you're going to have a quiz. It won't be next time, but the time after that. And you'll be writing some equations of lines and finding slope. All right, let's look at part 5 and see what's going on there. By the way, I don't know if you guys realize this or not, but we have been so fortunate. We have met every day of the school year so far.
Yeah.
You've enjoyed it, haven't you? But tomorrow I don't see you.
Can you bring us cupcakes on Friday?
You can bring them.
You know
All
what?
right,
That sounds
so
like a good
here we
idea.
go. Now we're going to write in the equation of a line, and it's going to be parallel to this one, and it's going to. All right, we're still writing the equation of a line. It's parallel to the one that's parallel to this one, and it goes through that point. Now, no matter which method you use, and I don't see any directions here as far as use point slope or use slope intercept, so you don't really, it doesn't really matter to me. But no matter which one I choose, what do I have to have? I have to have a point, and I have to have a slope. So here's the key. You're not going to find slope doing y minus y over x minus x because they only gave you 1 point. But they did tell you that your line has to be parallel to the one they gave you. Okay, so what do you remember? Now, even if you forget, just think about it.
The slope is
Parallel
the same.
lines. What do you know about them? They have the same slope. So if I look at this equation, y is by itself, so isn't this mx plus b over here? So m is 3. So my slope is 3. And now I can write my equation. So y minus 3, that's this 3, y minus this 3, equals m times x plus 2. So if I work it all the way out, I get y equals 3x plus 9. If you found this equation and this equation in the hallway, you would know they were parallel because they have the same slope. That's what parallel means in algebra. It means the slope is the same. So here's the point slope form, here's the slope intercept form. I did both because I don't know how it'll be on the test. Sam, you follow?
Yep.
All right, now, Sam, let's look at B. B is really the same question, but instead of being parallel, the lines need to be perpendicular. Wait. So I got a different equation. And I got the point. And I want to come up with a perpendicular. Okay? This is a little harder. Anybody remember the relationship between perpendicular lines?
Reciprocal.
It's the opposite reciprocal slope. Opposite reciprocal slope. Opposite reciprocal slope. So if you don't remember that, you might want to take a note so you can look at that a couple of times and remember. So let's make sure we understand what opposite reciprocal means. If we had a slope of 5, negative 1/5. If we had a slope of 2/3, negative 3/2.
Yeah.
So you gotta flip it and make it negative, okay?
Or make it positive.
Or make it positive, that's right. If it's already negative, you gotta make it positive, so change the sign. Okay, how do I even begin finding the opposite reciprocal slope? What do I need to do, Pat?
We first need to find the slope of that.
And how do I do that?
First you would subtract 2x to the other side, and then divide everything by 4, or negative 4.
Negative 4. He gave me specific steps. What he's actually doing is getting y by itself. That's what you gotta do, right? You gotta get y by itself. So he was right. His steps are, I'm using this equation, so I'm gonna move the 2x over. Notice I'm subtracting it. And then like Pat said, we're gonna divide by negative 4. So y ends up equaling what? 1/2 x minus 1/4. Now, the 1/4 is awesome, but I really don't care about it because when I'm dealing with parallel and perpendicular, all I look at is the slope. So I'm interested in this number right here. The slope of that line is 1/2. I want the opposite reciprocal because this is a perpendicular problem. So what slope am I going to use? Negative 2 over 1 or just negative 2? So my slope is negative 2. Everybody with me? You got to pay attention to whether you're doing parallel or perpendicular. If you were doing parallel, you'd use 1/2. All right, so here's my point. So y minus 3 equals negative 2x plus 2. Y minus 3 equals negative 2x plus 2. I came up with as my answer y equals negative 2x no one ever calls me.
And it was like 1.0.
I guess it's from who do I know in Oregon? No one. Okay. All right, so this is what I got. Is this what you got?
Yeah.
So why can't you just keep the same line intercept from the last equation?
Because the parallel line is going to have a different y-intercept than the
Well, no, I mean, you already found the equation being, so you already have the y equals 1/2 x.
This one right here.
Yeah, so why wouldn't you just keep that one?
Well, because think about it. If okay, so the given line has a slope of 1, so here's like the given line. That's what it looks like. The point in question is negative 2, 3. It's over here. And I am writing the equation of this line. The way I do it, it does look the same. There is, so it's not going to cross the x-axis, or excuse me, the y-axis in exactly the same place. This is a new line I'm drawing.
Wait, never.
Okay. All right, let's see what's next. We need our calculators today. So, here's what, since I didn't warn you, we'll do the algebraically part first, so we'll come back and do the calculator part. Friday, bring your graphing calculator. So remember, if you don't have one of your own, which you were supposed to buy one last year, but if you don't have one of your own, you need to get one, either check it out from the library or borrow it from a friend or something, but you gotta have a graphing calculator that you know how to use. So we're gonna save the graphing problem since I didn't warn you yesterday. I'm warning you now, Friday is a requirement, all right? If you don't bring one with you on Friday, I'm gonna make you rent one from me, all right? It's gonna cost you 50 cents to have a calculator on Friday if you don't walk in the door with one, so please bring one on Friday. So we're gonna skip part one for the moment. We're gonna do that on Friday, and we are gonna look at part two. You do not get the money back, you are renting it. So bring the calculator. It's pretty simple. All right, here we go. Number 2, solve this. We are embarking on section P5, which is the section where, so turn the page.
Oh, so no.
We're on number 2, we're gonna save number 1. We're gonna save number 1 for Friday,
Oh, I got this.
when everybody has a calculator. So we're on number 2. We're on number 2, where we don't need a calculator. We're gonna solve using square roots.
Got it.
What that means is, we're gonna take the square root of
Everything.
both sides. Now, technically, you're supposed to divide both sides by 4 first.
Why would you do that? Makes perfect
Now, in the end, it isn't going to make any difference. So if you forget to do that, don't want to do that, it's perfectly okay. We're gonna get the same answer.
So
I'm telling you, because I'm trying to be a good math teacher, technically, that's what you're supposed to do, but it really doesn't matter. Now, I'm gonna take the square root of both sides. So what's the square root of x squared? X. What's the square root of 25 over 4? 5 over 2. I'm missing something. Anybody know what I'm missing? Ah, very good. Plus or minus. Any quadratic equation, this is called a quadratic because it has an x squared. Any quadratic equation is going to have 2 answers.
I am stupid.
When you solve it, you're going to get 2 answers. How do you get the 2? You take plus or minus. Okay? So look at the next one. Oh, it looks a little harder, but I don't think it is.
It's just simply not.
How do I do the next one?
So the radicals of everything.
Yep, take the square root. Now,
Powers draw.
somebody might say, well, why don't we FOIL it out? No, that would make it worse. We have a square on both sides. This is a square and that's a square. So we're going to square root both sides. What's the square root of x minus 3 squared?
X minus 3.
X minus 3. What's the square root of 25? Plus or minus 5. Do not forget your plus or minus. So x is going to, well, so we have x minus 3 equals 5, and we have x minus 3 equals negative 5. How many answers are we going to get? 2. So x equals 8, or x equals negative 2. You don't plus or minus your final answer. You plus or minus when you take the square root. So when I took the square root of 25, that's plus or minus 5. When I took the square root of 25/4, that was plus or minus 5/2. You take the plus or minus at the moment you square root. Okay, got it?
Yeah.
All right, try C. What do you think about C? I don't know, somebody says.
Divide by 3.
Oh, I love it. Whoever said that, you are right. We're gonna start by dividing by 3. Now, in this case, kids, it is going to matter. Actually, ultimately it won't, but it's gonna make our work so much easier if we just divide by 3 right now. I would absolutely divide by 3 right now. So I'm gonna have x minus 4 squared equal to, whoops, not 9, equal to 3.
Wait, how does it change the parentheses?
It didn't change the parentheses.
You don't need to.
No, we divided by 3 and those cancel. So it's just x minus 4 squared. Now what do I do?
Radical over both.
Square root?
2 drops.
So the square root of x minus 4 squared is x minus 4. And the square root of 3
That stays.
is
It just stays that way.
plus or minus the square root of 3.
So then you're gonna get
So we're gonna get
Over
x
3.
equals 4 plus or minus the square root of 3. Now you can split that up if you want,
oh you
but
would
if you split it up, you don't have to do this one. If you did, this is what's gonna happen. On this side, you're gonna get 4 plus the square root of 3, which doesn't simplify. It isn't like this, where we can make that an 8. This stays 4 plus root 3, and this one stays 4 minus root 3. So if you want to write those separately, you absolutely can. But you can also, because they don't simplify, you can put them together. Yes, ma'am.
So do you only add like the 4 to the side with the square root if it's not a perfect square? Because,
No,
like,
you add that number always. In this case, when we added 3, we were adding it to 5. So this is actually 3 plus 5, but we can go ahead and make that 8. And this is actually 3 minus 5, so we can go ahead and make it negative 2. No, you always add that number
I
over.
didn't see that part.
Yeah. All right, one more. Here we go. What are we gonna do here? We're gonna square root both sides?
Yes.
Now, do you notice the difference between the 2 here and the 3 here?
Oh, wait, hold on. Can we square root it
We can absolutely square root
and
it.
make it 4 equals 2x plus 1
So 2x plus 1
equals 4?
equals plus or minus 4. Remember, when you take the square root of that number, you gotta do plus or minus. So Logan interrupted me, which is fine.
I'm sorry.
Do you see the difference between this 3 here and this 2 here?
Yes.
Yeah. If it's outside the parentheses, go ahead and divide it out. If it's in there, you just gotta keep it. So 2x plus 1 equals 4. And 2x plus 1 equals negative 4. So 2x equals 3 and x equals 3 halves. Or 2x equals negative 5 and x equals negative 5 halves. How many answers should we have when we do a quadratic?
Those.
2. There they are. What?
Will they ever be the same?
They can be the same, probably not in a problem like this, but you will see when we do some other methods, you can have 2 the same. The only way we would have 2 the same is if this number over here was a 0. Because when you do plus or minus 0, it's the same thing, so your multiplications will go on. All right, we got one more piece of action today, folks. This is a doozy.
Oh gosh.
I know, hang on, you got it.
No, I
We're
don't.
going to
I know how to do this, wait.
complete the square.
Can I just factor it?
Somebody said, can I just factor it? Absolutely. Out in the real world, if you come across a quadratic equation and you need to solve it, you can solve it any way you want. The problem with factoring is it doesn't always work. So you can't just factor because it doesn't always work. That's why we have these other methods. All right? That one factors, and when I'm done with it, I'll remind you what it means to say it factors. But we're not factoring it, we're practicing by completing the square. All right? So here we go. Does anyone remember how we even start this? Yes, ma'am.
So, okay, I don't know how to explain it. I'm gonna try to make it make sense.
Thank you.
So, yeah, I know you need the factors of -7, which would be 1 and 7.
Okay, now
But
you're
one number has to
factoring.
be a negative.
Yes, you're exactly right. And when I go to factor this thing, I want you to explain that. But that's not completing the
Oh.
square.
Well, I know like it has to be like x plus 1 times x minus 7.
You got it. You totally got it, but you're using the wrong method. Look at problem B. What you're doing won't work with B. So I want to practice on an easier problem, how to complete the square, and then we'll do this harder problem. All right? So, first of all, I totally love that you remember how to factor because that's a very important skill. Very important. But I need you to set that aside for just a moment and complete the square. Who remembers anything about it? What'd you say, Shiloh? Move the 7 over. That is exactly right. That's his name, right?
Yeah.
So yeah, we're gonna add 7 to the other side. That is exactly right.
Sorry.
And notice that I left a little blank space in here because I am going to add something to both sides of the equation.
I remember this part now.
You remember this
That
part
part comes
now?
back now.
All right. So do you remember how we figure out what we are going to add in that blue blank?
Do the formula this time.
Okay, that greatest common factor is always a good guess, but it's not right in this case. And you think of any other strategy we might use. Do you remember this at all?
Use the formula for the same answer.
So let me give you a hint. It has to do with taking half of this number
-3.
and then
It'd be 6
squaring
and
it, and then squaring it.
Why?
So make a little note. You take half of the x coefficient, so whatever number is right here, take half of it and square it. So half of 6 is 3, and 3 squared is 9, and that's what we're gonna put in the blue blank. So one more time. Once you move the 7 over, like Shiloh said, we're going to take half of that x coefficient and square it.
Doesn't do
Now,
anything.
you did that so that this right here could factor into a perfect square. It's why we call this completing the square. This is going to factor into a perfect square. So how would that factor? X?
-3.
Yes, ma'am. You're the factoring queen. X minus 3 times x minus 3. And then this side over here is 16.
Oh, good. Why would you write it twice?
Is
that the only way to do it?
Now we square root both sides. So x minus 3 equals plus or minus 4. So x minus 3 equals 4, x minus plus 2. So x equals 7, or x equals -1. Now, I am 100% in agreement. Why
That's
didn't
a
you
lot of
just
work.
let me factor it? I agree 100%. but I hope you listen to me.
No, I
Not everything factors.
That's for a pretty complicated problem.
Is that the only way you can like do that?
You either are going to come, no, this one factors. So you could have just factored, how did you say it factored?
Oh, it was -7 and positive.
X minus 7, X plus 1?
Yeah.
And then you set those equal to 0,
Just wasn't-
and you get X
X
equals 7 or X equals -1. So it does factor. I completed the square because that's what the directions said, and I'm a rule follower. Or you also might have used the quadratic formula, which we'll talk about on Friday.
That thing is so much better.
But first, we have to do one more completing the square problem. All right, so I'm gonna leave that one up there. You got it in your notes. Let's use it as a model. And we're going to complete the square. Actually, we have 2 more to do. X squared plus 8x minus 2. Now, try as you might, this is not going to factor. You are not going to be able to do that.
Add 2 to the other side.
So we'll add 2
And leave a space.
and leave a space. I'm going to mark it with my nice blue marker.
So will always be add.
It'll be
Always
16.
be add.
Okay.
Always be add.
It'll be 16.
And it'll be 16. Because to figure out what it is, I take half of this
Yeah.
and square it.
That means it can only be one answer.
Yep. Now, the next step, this is where you gotta remember what you're doing. You're completing the square. So this is going to become a square. You're gonna factor that into 2 parentheses that are exactly the same.
Oh, that's wrong.
They gotta be the same.
X
So
plus
4 and 4. So it's gonna be x plus 4.
Yes, right.
Now, want to show you something, might help, I don't know, maybe you don't need it, but when you do your perfect square, if that's a minus, this is going to be a minus. If that's a plus, this is going to be a plus. Okay, every time. And that's going to equal 18.
Yeah.
Yep.
So now what do we do? Square root it. So x plus 4
Equals 3
Three
root 2.
equals
Yeah.
plus or minus
3
what?
root 2.
3 root 2. Now those of you that are saying, 3 root 2, where'd that come from? Remember, the square root of 18 breaks down.
Will you show us how to like finish that, or is that just the last
We're
thing?
not done. The last step, move the 4 over.
Okay.
Now again, there is no way to combine these. So if you want to write them separately, you can, but it would be -4 plus 3 root 2 and -4 minus 3 root 2. So normally we write them together like that. You can't do that if they break down, if they simplify. If they simplify, you got to write 2 separate answers. What?
The rule multiplies for 8 adds for 16. Where's the other one?
Uh-huh. No, it multiplies to 16 and adds to 8. All right, there's one more, guys. Here we go. All right, let's look at it carefully.
Oh, you can take a 2 out.
Exactly. Did you hear what Gabby said?
Take a 2 out.
Step 1, get rid of the 2.
Divide by 2.
And when I say get rid of it, I mean get rid of it. Gone. The 2 is gone. So we have x squared minus 10x plus 2 equal to 0.
Yes.
Beautiful. That's how you want to start. If you've got a coefficient out here, PJ, you got a coefficient out here, you divide it out. Get rid of it. Now what?
Oh, you did subtract 5 or subtract half of 10.
Not yet.
Subtract 2.
Oh, 2.
I
I
gotta
wrote that.
move the 2 to the other side. And the reason you're moving it is so that you have room to put in your new number, right?
Yeah.
What's my new number gonna be? 25? Everybody okay with 25?
Yeah.
Half of 10 squared. Now, this is gonna be a square. X minus 5, perfect. Everybody get that? X minus, cause that's a minus, and then 5. Because 5 times 5 is 25, 5 plus 5 is 10.
Just to make sure it's 25 squared times 5, right?
No, 25 on both sides. We add the same thing to both sides. So if you put a 25 on the left, you're putting a 25 on the right. But there's already a negative 2 over there, Maddie, so it actually becomes 23 over there.
So they can't.
Because you move the 2 over.
But isn't 23 a prime number?
It is.
So is that we just leave the rest of that?
Well, it just means we're gonna have an answer that looks like this.
You'd radical the x minus 5.
Yeah, we're not done yet. We need the square root.
Power drop.
So x minus 5 will be plus or minus root 23.
You're gonna get.
Nope.
And if you, because you still have a radical, you're not gonna be able to combine these. But if you wanna split it, you can.
X is
I'm
equal
just
to
gonna
5
move
plus or
the 5
minus root
over.
23.
So x equals 5 plus or minus the square root of 23. Anytime that your problem does not factor, you're gonna end up with a wacko answer like that. If your problem factors, you'll get a nice neat answer. But if it doesn't factor, that's what you're gonna do with the test.
Is it important that you stick that 5 in front?
What?
Is it important that you stick that 5 in front? Yeah, that's not.
No, you can say plus or minus root 23 plus 5, that would be okay. Almost always, this is how we write it, but it's fine. We write it differently. Okay, so, what are we all bringing on Friday?
Calculator, graphic.